All right, today we're putting on our data detective hats. Our mission? To uncover the secret groups hidden in plain sight all around us, from the stuff you buy to the stocks people trade. The technique is called clustering, and you're about to see just how powerful it really is.
So let's start with a question you've probably asked yourself. How do companies seem to know exactly what you want? How does your streaming app recommend that perfect movie you didn't know you were looking for? Well, it's not magic. They're finding you in a crowd, and clustering is their secret weapon.
Take retail, for example. This is what they call customer segmentation. It's all about sorting out the weekend bargain hunters from the high-spending loyal customers so they can send the right offer to the right person at the right time.
Or how about banking? They use it for fraud detection. They basically figure out what millions of normal transactions look like, so when one weird purchase pops up that doesn't fit the pattern, bam, it gets flagged as potential fraud instantly. And in the world of finance, it's absolutely essential for managing investment portfolios, grouping similar stocks and assets together to build a balanced portfolio that isn't too risky. And honestly, these are just a few examples. This stuff is happening all around us, all the time.
So let's get our hands dirty. Imagine we're working for a retail company, and we are sitting on a literal mountain of customer data. Our job is to dig into this mess of information and find the meaningful, hidden groups that are going to shape our whole strategy.
And believe me, the stakes are high. Right now, our marketing is just one size fits all, and it's not working. Our click-through rates are dropping, and worse, we're losing customers. But if we can figure out who our customers really are, we can tailor our offers, boost engagement, and seriously cut down on the number of people leaving. That's the goal. Okay, so where do we even begin to find these groups? Well, the very first step is to answer a simple question. What does it mean for two customers to be similar? And in the world of data, similarity is all about distance. The closer two things are, the more alike they are. Simple as that.
Now, to measure distance, we've got a couple of options. Think of Euclidean distance as a helicopter flight. It's the direct, straight-line path as the crow flies. But Manhattan distance is more like a cab ride in a city, where you have to follow the grid of streets. Neither one is better than the other. The one you pick just depends on the kind of problem you're trying to solve.
With this brings us to our first big snag. What happens when we're comparing, say, a customer's income, which might be like $50,000, with the amount they spend on wine, which might be just a couple hundred? That giant income number is going to totally drown out the smaller number, making the wine spending pretty much invisible to our algorithm.
And here's the brilliant fix. It's called scaling. We use a little something called a z-score. Now, don't worry about the name. It basically just puts every single variable onto the exact same playing field. So now, look at this. An income of over 71 grand and wine spending of 226 bucks end up with really similar scores. All of a sudden, both of these things matter equally. It's a total game changer.
Okay, our data is prepped, it's scaled. It is time to unleash our main tool for this quest. K-means clustering. It's a really powerful algorithm that's going to sort all our data into a specific number of groups, and that number of groups is what we call K.
The logic behind it is actually pretty elegant. First, we just randomly drop K starting points, we call them centroids, into our data. Then, every single data point gets assigned to whichever centroid it's closest to. After that, we move each centroid to the new center of all the points that were just assigned to it. And then, we just do it again. Assign, move, over and over, until the centroids finally stop shifting.
Now here's the catch. Where you start really matters. If you get unlucky with the random placement of those first centroids, you can end up with some really weird, illogical clusters. That's why people invented smarter techniques like K-means++, which helps pick better starting points to give the algorithm a much better shot at finding the real groups. And this brings us to the million-dollar question. We know how K-means works, but how in the world do we choose K? How do we know if we should be looking for 2 customer groups, or 3, or maybe even 10?
To find the best K, we need a way to score our results. We use a metric with a pretty intimidating name, Within Cluster Sum of Squares, or WCSS. Just ignore the name. All you need to know is that it measures how tightly packed each cluster is. And for us, a lower score is better. We want tight, compact groups.
So, let's try it out. We run the algorithm and tell it to find just 2 clusters. It runs, and we get a WCSS score of 580. Okay, that's our baseline. The question is, can we do better?
Now, let's try it again with K equals 3. And whoa, the score plummets all the way down to 320.
That is a massive improvement. It means our 3 clusters are way tighter and more compact than our 2 clusters were. This feels really promising. But shouldn't we keep going?
So what we do is we plot all our scores for different values of k, and we get this famous chart. We call it the elbow method. Just look at that steep drop in the score as we go from 1 to 2 and then to 3 clusters. But see what happens after k equals 3? The line starts to flatten out. That sharp bend right there, that's our elbow. It's the sweet spot, the point of diminishing returns, where adding more clusters doesn't really give us much more bang for our buck.
So we found it, 3. 3 is our magic number. But we're not done yet. Right now, these are just numbers in a computer, abstract blobs of data. The final, and honestly the most important step, is to breathe some life into them and figure out what these groups actually mean.
So we look at the first cluster, and we start analyzing its character. What do we see? High incomes, high spending on wine, and they shop with us all the time. So we give them a name. Let's call them the connoisseurs. Just like that, it's not an abstract group anymore. We have a clear picture of who these people are.
Then we look at the second group, and its profile is basically the exact opposite. They have lower incomes, they spend very little on wine, and they're infrequent shoppers. We can call them the savers. And right there, by defining these profiles, we can now build completely different marketing strategies that are perfect for each group.
But wait a second, this was pretty straightforward because we were only looking at a few things. What happens when your analysis has, 20 different variables? Age, income, location, last purchase. Our human brains just can't visualize a 20-dimensional space. How could we possibly see if our clusters even make sense?
Well, this is where a little bit of mathematical magic called TS&E comes into play. Think of it like trying to create a flat map of our round Earth. Of course, there's going to be some distortion, but the main goal is to keep the continents in the right places relative to each other. TS&E does something very similar for our data, squashing dozens of dimensions down into a simple 2-dimensional map so we can actually see the clusters and how distinct they are from one another.
From customer behavior to genetic codes, clustering gives us a lens to find structure in what looks like pure chaos. It turns these vast oceans of raw data into meaningful groups we can actually do something with. And maybe that's the real key takeaway. The patterns are already out there, hiding in plain sight. We just need the right tools to see them. It really makes you wonder, what hidden groups are just waiting to be discovered next?